Okay, so I have this extra topic in this section. We want to discuss the standard equation of a circle here. And this is something that you should know, especially if you're going to take calculus. Everybody should know what a circle is coming out of college algebra, and how to recognize the equation of a circle. In the textbook, this is covered way back in the first section, and that section was on basically introducing graphing, and I thought that seemed pretty elementary for a college algebra class, so that's why we skipped most of chapter 1. Most of the topics there are from intermediate algebra and prerequisite material. But unfortunately, this topic was in that chapter, and we should cover at least this one topic. So let's go ahead and do it. This formula for the equation of a circle is basically just using the distance formula here. So I'll just draw a picture. If we have the xy plane and we take a point in the plane, this is going to be the center of our circle, and call it HK. Then of course, if we go in any direction the same distance, we're going to pick up a circle, and this distance is the radius of the circle, of course. So think of the point on the circle as something that can vary, but it has to at least be on the circle. So these are variables on the circle. Then we could find the radius using the distance formula. Recall the distance formula. So this is something that you should know from your Math 902 class or equivalent course. Hopefully you remember, at least vaguely, that it's the square root of the difference in the x coordinates squared plus the difference in the y coordinates squared. A little bit of review there. Well, if we use this formula for the radius, because that's the distance between any of these points, hk is fixed, x and y are the variables. They can be anything, and this should reduce to the distance, r. So r equals the square root of x minus h squared plus y minus k squared. Well, if you square both sides, r squared is x minus h squared plus y minus k squared. This is what we call the standard equation of a circle. Now we put this on the left and this on the right normally, but I'll write it that way right here. So x minus h squared plus y minus k squared equals r squared, where hk is the center. So of course that's not a point on the circle, it's just a reference point that helps us graph it. And r is the radius of the circle, of course. Whoops. Radius, there we go. So if we know the center and the radius, we should be able to plug those in and find the equation of the circle. So the first one, center is 0, 0. Whoops, sorry, writing too fast. Y minus 0 squared equals, and then r is 8. So this, when the center is 0, 0, the x minus h squared plus y minus k squared collapses to x squared plus y squared equals 64. Anytime you have x squared plus y squared, that center is 0, 0. B, we've got x minus h is the x coordinate, so 2 squared, plus y minus negative 1 is the y squared, or y coordinate, excuse me, so negative 1, sorry, y minus negative 1 becomes y plus 1 squared, and then the square root of 5 squared is 5. All right, so this is the standard form. That's the most useful form because we can see the center and the radius just by inspection, basically. The general form is less helpful because if you have the general form, you need to get it in standard form to find the center. But sometimes you're given the general form, so what is it? Well, it's basically if you took this and expanded it, you'd get the general form. So I'm just going to come down here. If I square this, I get x squared minus 4x plus 4. If I square this, I've got plus y squared plus 2y plus 1 equals 5. And then add like terms. The like terms are the constants, of course. 4 plus 1 is 5. And then 5, so you'd have plus 5 equals 5, but you would still combine, move the constant over here, set the equation equal to 0. That would be general form. So in more general, of course, this is just a particular circle. General form is ax squared plus bx plus, no, sorry, not a. A is 1. Let's make this an a. Plus y squared plus by. No, I'm going to go back to a and then make another comment. Bx plus a y squared plus cy plus d equals 0. The constant doesn't always go away, of course. These just happen to cancel. Now, d is here. A, technically these are 1s like I was going to write. But I want to point out that they might not be written as 1s to begin with. Right, I'll put a equals 1 here. But they're the same. These have to be the same in order to be a circle. Okay? If this is a 2 and this is a 4, it's not a circle. It's actually an ellipse then, which we're not going to get into, but those have to be the same. But basically it's all expanded, okay? And then it's called general form. And then we would have to go backwards to get it into standard form. And that's what we're going to do in this example. So notice this is all expanded. This is our general form. It's all expanded out. So we want to rewrite this x squared minus 4x, the x's together. This is where the completing the square thing comes into that I was talking about. And then y squared plus 12y. And then, we're going to add a number here and add a number here to complete these squares. And then this 9 we're going to put to the other side. Whatever we add here and here, we have to add to this side to keep the equation balanced. So in the x's, what completes the square? We would take negative 4 divided by 2, which is negative 2, and then square that. I'll write it as negative 2 squared, which is of course going to be 4. So that's a perfect square. And then for the y's, the 12 divided by 2 is 6, and then we're going to square that. And of course that's 36. So now I have another perfect square. And then because I added 4 and 36 to the left side, I need to add 4 and 36 to the right side. 9 plus 4 is 13, and then that adds up to 49. Okay, so these perfect squares, that's what's going to make it so that I can get these two perfect squares in the standard form. So the first one is x minus 2 squared, and this one is y plus 6 squared equals 49. So there's the standard form, but I'm not done with the problem because it's asking for the center, and the center, then we can pull it out of here. Notice in the standard form it's minus h and minus k. So what are you subtracting here? Subtracting 2. In here it's a plus, so you're actually subtracting negative 3. So whatever signs these are going to be the opposites. And then the radius is the square root of this number. If this is already squared, you need to take the square root. That's 7. Now if that already said 7 squared, then you just pull out what's on the inside. So that's part of our answer as well. Okay. So let me go back to this general form because this is bugging me. I shouldn't leave this like this, but I wanted to point out if this could happen where these aren't 1s, and then I'll leave it. The coefficients don't matter, right? So I could do A, B, and C here, but I'm not going to. You have to have the x squared and the y squared term, but these terms could be missing because you might be centered at 0, 0, right? So keep that in mind. When you're doing this, process, this number could be negative, but once you complete, like this could have started out as a negative. Once you complete the square, however, and then add these numbers, this has to be positive in order to have a radius. Okay, so if you get a negative here, and then your radius is square root of a negative number, that means you made a mistake somewhere. So make sure you're not doing that. All right, and one more example, and this is looks like the square root function, right? But notice the x squared here. We're not talking the square root of x. It's not going to be a translation of the square root of x. Instead, this is related to the circle. Notice that if you took this y equals square root of 25 minus x squared, and if you square both sides, y squared is 25 minus x squared, add x squared to both sides, x squared plus y squared is 25. That's a circle with a center 0, 0, and then the radius is 5. But this is actually not the full circle. If we go backwards, okay, so this seems weird. Why are we going in circles, right? Go back. Solving for y squared is 25 minus x squared. When we take the square root of both sides, we actually get plus or minus the square root of 25 minus x squared. There's two signs here. So what's happening here is instead of this full circle, this is only starting as the positive root. In other words, y is only positive. This is actually the top half of x squared plus y squared is 25. It's not the full circle. So if we know it's centered at 0, 0 and the radius is 5, it looks like this. Okay. Notice this is a function that if you plug in an x, you only get one output. So in general, you can kind of make this generalization here. Y equals, let's use function notation. These are actually functions. The square root of, so anytime you would take a circle x squared plus y squared equals r squared and solve for y, notice you'd get r squared minus x squared, and the y is plus or minus the square root of r squared minus x squared. The positive will be the top half of the circle because the y's are all positive up here, and the negative will be the bottom half of the circle. So if you only have the top half or the bottom half, then you do have a function. If you have the full circle, of course, you don't have a function, right? So in general, r squared minus x squared is the top half of, or in other words, it's a semicircle, right? The top half of the circle x squared plus y squared equals r squared. And f at x equals negative square root of r squared minus x squared is the bottom half of x squared plus y squared equals r squared. The bottom, because here the y's are all negative, so you would just get this set of points. Okay, so you'll sometimes see this type of equation, and you should recognize the relationship of that between the circle, or with the circle, I should say. But keep in mind, this is a function. It's not the full half of the circle. unless we have both a positive and the negative root, then it's just one half or the other of the circle, not the full circle.